Hello everyone, welcome to another video of class 9 general science, and today we are starting off with chapter 3 atoms and molecules. So without wasting any more time, let's get started. So before we start off with this chapter, I would like to tell you that this chapter is going to be extremely essential for your chemistry foundation. In order to build a good foundation and understand in future classes and to understand chemistry better, atoms and molecules, this chapter is going to be extremely essential for your studies. So I would like you to pay close attention to whatever is discussed in the video and also in the book. So go by the book thoroughly, line by line, so that you can understand, get a good foundation build up, so that you can understand chemistry better. So without wasting any further time, let's dive into today's topics. So we are going to discuss about three things today actually, two laws and one theory. The two laws are laws of conservation of mass and law of constant proportions, and then we are going to move on to Dalton's atomic theory. So let's first understand what is law of conservation of mass. Now, conservation of mass, just like we have done conservation of momentum in other chapters like chapter 9, similarly here we are going to talk about conservation of mass. And by conservation of mass, what is meant is that whenever there is a chemical reaction, the reactant and the product. Now what does the reactant and product mean? Let me write one very simple chemical reaction, like carbon plus oxygen gives carbon dioxide. Okay, so these are our reactants and this is the product. Okay, so since they are reacting, there will be some mass of carbon, some amount of carbon and some amount of oxygen which combine together to form carbon dioxide. Now what law of conservation of mass states is that mass can never be created nor destroyed in a chemical reaction. Now what does this mean? It means that the amount of mass of particular element before the reaction and after the reaction will remain the same. So look here, carbon here there is only one atom of carbon, right? Here how many carbons are there? Only one. How many oxygen atoms are there? Two oxygen atoms are there. Here how many? Two oxygen atoms are there. So number of carbon before the reaction and number of carbon after the reaction is remained the same. There is no change in the mass of carbon. Similarly, number of oxygen before the reaction and number of oxygen after the reaction has remained the same. So we cannot write anything like C plus O2 gives CO3 and finish this as a reaction. You can't do that, because this will break the law of conservation of mass. What does this mean? If I want to write the equation like this, what does this signify? It signifies that I had one atom of carbon and two atoms of oxygen. I mixed them and what I got was one atom of carbon and three atoms of oxygen. Where did the other atom of oxygen come from? By magic. There is no magic or black magic in chemistry. In chemistry, everything is followed by laws, and we have this law that nothing can be created or destroyed. You cannot even write CO, that we are vanishing one oxygen atom. We cannot vanish or we cannot create anything. Whatever was there will remain there. So this is going to be the right version. Okay, so what is there before the reaction, what is there after the reaction should always maintain each other, means they should balance each other out. It should not outweigh in any part. It should not be more towards the left or towards the right. This part we call the reactant part. So from now on, every time I say reactant, it will mean this part, and every time I say product, it will mean the right hand side. Okay, so this is what law of conservation of mass is. Very simple. The amount of any element before the reaction and the number of or amount of element after the reaction remains the same. Now we move on to law of constant proportions. Now law of constant proportions means what? It means that suppose you take any compound or any molecule, anything. The simplest example is water. So you take water from anywhere. You want to take water from sea, from any river, from the pond, from your tank, from the pipeline, anywhere, from anywhere you take water. If you take water, you will always find that the amount of oxygen and hydrogen in water are always in the same ratio. Now what do I mean by that? What is the formula of water? Formula of water is H2O, known to everyone. H2O is the formula of water. Now does this formula change if you take the water from sea, or if you take the water from any river, or if you take the water from any pond or your pipeline? This formula does not change. It remains H2O always. Now what do I mean by this constant proportion? The mass of hydrogen is 1. How many hydrogens are there? 2. So it is 1 into 2, that is in water we have 2. Suppose we want to express it in gram, okay. So suppose it is 2 gram of hydrogen in the water. Now what about oxygen? Oxygen's mass is 16 gram, okay. You will learn about what is atomic mass and everything else you will learn. Just for now, just know this is a fact that hydrogen has a mass of 1 gram, and since there are 2 atoms of hydrogen, we have 1 to 2, that is 2 grams. Oxygen, there is only 1, and each oxygen atom has 16 gram mass. So that means what is the ratio of hydrogen to water? Hydrogen to water ratio is 2:16, which is 1:8. So the amount of hydrogen to the amount of oxygen in water is always in the ratio 1:8. Now if I take the water from sea, pond, river, wherever, the formula always remains H2O, and as a result the ratio will always remain 1:8. This ratio never changes. Hydrogen to oxygen will always be 1:8 irrespective of from where you take the water. Similarly, suppose you take carbon dioxide. Okay, what is the mass of carbon? Mass of carbon is 12 gram and mass of oxygen is 16, but how many oxygen we have? We have 2 oxygen, so it is 32 gram. So what will be the ratio of carbon is to oxygen? It will be 12:32. 3:8. So it is always 3:8. So carbon to oxygen is always 3:8. The ratio between carbon and oxygen is 3:8 in carbon dioxide. So it does not matter from where you obtain the carbon dioxide, the ratio is going to be same. So that means you take any compound, any molecule, any mixture, whatever you take, that very compound, irrespective of where you have obtained it from, the ratio of the atoms or the ratio of the elements present in that compound will always remain the same. The proportion, they will always be in the same proportion. That is 3:8 in case of carbon dioxide, 1:8 in case of water. Similarly, other compounds you take and you try to find out this ratio of the mass, and this ratio always remains the same. So it does not matter, the source of the compound does not matter. Rather, what matters is what is the compound. For that very compound, in any place of the earth you take it from, why only earth, in any place of the universe you take it from, that very compound is going to have the same ratio. So that is why it is called the law of constant proportions. That means the compounds will always have similar proportions of elements in that very compound irrespective of where you take it from. So I have repeated the same thing over and over again a lot of times, so I hope you understand this one. So these are the 2 laws that we are talking about. Now we will move on to the atomic theory. So in order to understand atomic theory, we must have a concept of atoms. Now we will move into atoms, we will move into detailed discussion of atoms in our next video. Now let me just tell you that atoms are the building blocks of anything. Any compound, any molecule you want to assess, the building blocks of those are called the atoms. And a very common analogy that we give is, suppose there is a room, suppose this room where I am making this video right now, suppose this board. Now this, okay, let's not talk about the board, let's talk about the room. In this room we have walls, right? We have walls making a room. Now what is the wall made up of? What are the blocks that make up wall? Bricks. Now one brick cannot make a wall. So what we do, we put brick after brick, brick after brick, and a combination of brick makes a wall. In the same way, we take atoms, we mix atoms one with the other, we combine atoms to form a molecule. So in order to form anything, we need a combination of atoms. Even a single atom can form a molecule, we will look into that later. So atoms combine to form molecules. That means without atoms we cannot have molecules. So atoms are the smallest possible particles in a compound or in anything for that matter. Okay, anything that you look into, even yourself, your whole body is made up of atoms, combination of atoms. So now there is a scientist called John Dalton. Now John Dalton was the first person to use the term atom and then have his own atomic theory on what he understood based on his observations, that what are actually compounds, how are compounds made, and what is the role of atom in that. So let's move on to the laws that Dalton proposed on his Dalton's theory of atom or Dalton's atomic theory. So here we are into Dalton's atomic theory, and what are the points that he mentioned? He mentioned these 6 important points from his theory. So what does it start with? It starts with all matter is made up of tiny particles called atoms. So he tries to imply that everything that we see around us, all sorts of matter, are made up of tiny particles called atoms. That means atom is the building block, as I have mentioned earlier. Next point is, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. You cannot break atoms into smaller particles. That is what is meant. It is an indivisible particle. You cannot break it down into simpler particles. So that is the smallest particle and indivisible, which we can combine together to form atoms, but they cannot be created or destroyed in a chemical reaction. You cannot create an atom or destroy an atom in a chemical reaction, just like I showed you in the law of conservation of mass. If there are 2 atoms of oxygen, the number of atoms after the reaction also will remain 2. You cannot just vanish or create one new one. Okay, so you cannot create or destroy an atom in a chemical reaction, and it is also indivisible. You cannot break it down into smaller particles. Well, that's as of now. We will look into whether we can divide atoms, whether there is anything inside atom or not. We'll look into that later. So now let's move on to point number 3. Atoms of a given element are identical in mass and chemical properties. Let's look into point 4 as well. Atoms of different elements have different mass and chemical properties. So suppose I take oxygen. From anywhere on the earth, if you take oxygen, the atom present in oxygen will always be same. They will be identical. Identical means 100% same. So if you take atoms of oxygen from different parts or from wherever you want, the atoms of oxygen will always be the same. But if the elements are different, suppose I take 1 atom of carbon and I take 1 atom of oxygen, these two will not be the same. They will be different and always different. They will never be the same. Okay, so if you are taking a single type of element, their atoms will always be the same. If you are taking different elements, their atoms will always be different, both in chemical and physical properties. I hope you get that. Now moving on to point number 5. Atoms combine in ratio of small whole numbers to form compounds. That means, as for example, suppose let me write this one, H2O. So here we have 2 atoms of hydrogen and 1 atom of oxygen. So it says they combine in a ratio of small whole numbers. So atoms of hydrogen and oxygen, they are combining in ratio. What is the ratio? 2 atoms of hydrogen and 1 atom of oxygen. This is the ratio, 2:1. So these are all whole numbers, right? So whenever you find a compound, whatever compound it is, suppose I write another one, AlCl3 or C6H12O6, these are all molecules or compounds, and these molecules or compounds are composed of what? They are composed of atoms of each of these elements, but always in whole numbers. See here, 1 aluminium and 3 chlorine. Here 6:12:6. So these are always in whole ratios of whole numbers. Atoms always combine in ratios of whole numbers. Because why not in decimal or fraction? Because you cannot divide an atom. So if I write suppose H1.50, I cannot do that. I cannot have 1.5 number of hydrogen atoms. I cannot have 1 atom of hydrogen and another half, because you cannot divide an atom. So that's why you cannot have a decimal or a fraction. You always need to have whole numbers. So it has to be either 2 or 1. So it has to be a whole number. Okay. Now let us move on to the next one. The relative number and kinds of atoms are constant in a given compound. In any given compound, the relative number of atoms, number and kinds of atoms are constant. That means, suppose again I take the example of water. In this, the hydrogen atom is one type and oxygen atom is other type. So the relative number and kinds of atoms are constant. Relative number and kinds. In water, we are always going to have 2 atoms of oxygen and 1 atom of 2 atoms of hydrogen and 1 atom of oxygen. That is always constant. The number of atoms in water is always going to be constant of a particular type. Means there is going to be always 2 atoms of hydrogen and 1 atom of oxygen. Always in this ratio. And the kinds of atoms means what type of atoms we have. That is, in water we will always have hydrogen and oxygen. No other element will come in between them. Okay, so it is always going to be hydrogen and oxygen. So 2 kinds of atoms always in the numbering will be always 2 of hydrogen and 1 of oxygen. So that means the number of atoms of a particular type and the types of atoms in a particular compound, whatever compound you select, the number of atoms and the kinds of atoms are always going to be the same irrespective of where you obtain it from. So these are the 6 points that Dalton had pointed out regarding his observations on matter and how matters are made. It is all based on atoms. So in our next video, we are going to look into what are atoms, what are molecules, how are compounds formed and everything else. So I hope you understood this video and whatever has been explained. These are the very basics of this chapter. So if you have any confusion, make sure you ask me in the comment section or in WhatsApp or wherever you find it comfortable in. I'll be there to help you out. So thank you everyone for watching this video, and until next time, cheers.